All right, so today's learning target, we have two of them. First, we're going to be graphing sine and cosine functions with and without transformations. So we're going to kind of move the sine and cosine functions around the coordinate plane. Things are going to look very different from what we've been doing so far in this unit. And then there's a couple new vocabulary words that we need to focus on as it pertains to sine and cosine. Amplitude, period, and range. The ACT has started asking these questions more and more frequently. This is not technically part of our state standards for your grade level, but I always like to sneak this in Algebra 2 if I can. If you end up taking pre-calculus and trig next year, you will do a lot of graphing with these different functions. What I first want to show you is just a little video of how kind of the unit circle gets unwrapped to show what sine and cosine end up looking like. So our unit circle is in red, and then the blue is the value of sine of the unit circle. So what's going to happen, right, is within our unit circle, we know, right, we go counterclockwise, we move around the unit circle. Once we get back to where we started, what do? We go back around again, right? So this blue line that shows the sine function is just going to keep repeating over and over as we continuously go around the unit circle over and over. So within Desmos, what I'd like you to do is change your settings a little bit, okay? So I know we have worked with Desmos a little bit this year. You're going to click on the wrench in the upper right-hand corner there, and there's going to be a couple things we're going to change. Now, I restricted my x-axis to be between -6 and +6, and here's the big one. I changed my step value to be pi over 2. Now, how do you get the pi symbol in Desmos? You can just type in pi. You can find it also within the keyboard. It's just a little bit hidden. I think the keyboard shortcut of just typing in pi for pi divided by 2. That is going to be our tick marks on the x-axis. We're going to go up by pi over 2 increments. And then on the y-axis, I went from -3 to +3 with a step of 1. And then I think by default, it's already in radians, but just make sure the radians part is highlighted in green. Any questions on kind of setting that up? Because that is going to be important as we use it as our reference as we go through this. All right, so now that you have it in there, go ahead and type in sine of x. Or raise your hand if you need help kind of setting up your x and your y axis there. So type in pi over 2. It's actually pi. So pi. There we go. Now do divided by 2. All right, anybody else need a hand with that? So do we see that the sine curve, right, it repeats over and over and over again. So what we call these sine and cosine curves are periodic, which means they have a repeating pattern. Okay, so now let's have our notes out. It also would be great if you have your unit circle or a copy of that unit circle out as well. We're going to be referring to that a little bit. So the shortest repeating portion, so if I just look, okay, right, my sine function, it goes up and then down and then up. That is called a cycle. That is one full cycle, right? As soon as I kind of refer back to the beginning, I'm going to start repeating that cycle over and over and over again. One of our big vocab words today is what's called the period. It's the horizontal length of where that repeating cycle starts and ends. So part of today is just to calculate the period. And we're going to show how to do it both algebraically and graphically. I definitely recommend using Desmos a bit, right, as you're going through the homework to kind of check your work. Like, am I algebraically calculating some of these things correctly? It's going to be helpful. You'll see that Desmos can be much more helpful than your graphing calculator. Now, we can always put these into our graphing calculator, but I'll tell you, right, they're small. It's harder to zoom in. You won't have the nice kind of pi over 2 step features that you see in Desmos, so use Desmos as much as you can on this section. So let's go ahead and draw it. Right? I know, I'm going to make us draw it out. So I put our tick marks here, so we're going to do the steps just like they are within Desmos, pi over 2, pi, 3 pi over 2, 2 pi, and then our negative ones as well. And if anybody wants to use any of the colored pencils today, I've got some right here in the middle. Feel free to come up and grab any as we go through our notes. So instead of just looking at Desmos, to kind of figure out our points here, I want us to use our unit circle. So looking at your unit circle, what is the sign of 0? 0, right? We're looking at the y coordinate right now when we talk about sign. So the sign of 0, if I plug in 0 for x, I get 0 out for y. What is the sign of pi over 2? 1. So that's why at pi over 2, we're up here at 1. What is the sign of pi? 0. We're back down here at 0. And then what's the sign of 3 pi over 2? Negative 1. Right? And it would show that by the time we get back around to 2 pi, we're back up here at 0. So that is what the video did, basically, right? It unwrapped the unit circle to show that one full cycle of the sine curve. Now I'm going to do the same thing and just do it over here in the negatives too. I've got it. Now I like to put arrowheads on these, right, just to show that it goes on and on forever, that it's going to repeat that process over and over again. And because it's algebra 2 and we talk about functions, we like to talk about things like domain and range. So what is the domain of this function? What am I allowed to plug in for x? Anything, right? So write it as all real numbers, negative to positive infinity. At this point, right, we know these different notations. You can use whichever one makes the most sense to you. Now, how about range? Negative 1 to 1, right? The lowest it goes on my y-axis is negative 1, and the highest is positive 1. So again, feel free to write these in whatever notation makes the most sense to you, whichever one you like the most. It includes 1, yep. So that's why we use those brackets, right? And that's why, again, if you'd rather use the less than or equal to symbol, that's fine too. So if this is one full cycle, what is the period? Well, to figure out the period, I look at the x-axis, right? How far does the x-axis have to go before the cycle starts to repeat? 2 pi. So that's my period length. Questions on our sine curve? Go ahead and take out sine from Desmos, and let's put in cosine. Let's see what cosine looks like. Looks very similar, right? Now, some things are a little different, right? Maybe it's been shifted, or the numbers are slightly different. I'm going to fill out my x-axis with the exact same thing, right? Pi over 2's. And then the negatives as well. So let's try to create this as well using our unit circle. So let's look at our unit circle again. What is the cosine of 0? 1. So that's why I start up here at 1. What is the cosine of pi over 2? 0. How about the cosine of pi? -1. Cosine of 3 pi over 2 is 0. And then we're back around up here at pi over 2. So this is kind of what the cosine curve looks like. It's the same thing. It has the same shape. It's just when we think of it from starting at the 0 point, it kind of looks more like a dip, right? More like a dip. We're going to do the same thing on the other side. Draw as best. And then again, I like to put the arrowheads going on and on to show that it will be repeated. And I have a very similar answer to all 3 of these questions, right? My domain is all real numbers. My range goes from -1 to +1. And the period length, it just looks slightly different, but it is still a full 2 pi, right? One whole time around the unit circle is going to give me all the positive and negative values that I need for this function. Our next step, right, so we graphed sine and cosine, but now we're going to add in some transformations. Before we do that, though, go ahead and take out cosine and just put in tangent, just to see how crazy tangent looks. Whoa!
It's like a party.
It's a party, right? Tangent looks completely different. Let me see if I can pull it up too, so those. Right? Tangent is not periodic. It's not going to have the repetition. It does have the repetition, right? But it's not continuous. What these lines are here is they are called asymptotes. So if you look at your unit circle right now, what is the tangent of pi over 2? So look at pi over 2. I do sine divided by cosine. What do I get? Undefined, right? I'm trying to do 1 divided by 0. If I ever try to divide by 0, right, that's when the world comes to an end. The calculator can't do it. We can't do it in the world of mathematics. That's why you have all these breaks after each one of those pi's, right? Because those are the asymptotes. That's where you see undefined values for tangent. But that's crazy. We're not going to study that too much today, really, at all. So let's go back and start looking at some different things as it relates to, it looks like in our first one here. What are you looking at? Cosine. Okay, so go ahead and put cosine of x back in there. Because what we'd like to do is try to graph as much stuff as we can without relying on Desmos, right? We're trying to get a feel for these functions. What are they going to look like before I put them in there? Some things that we want to make sure we know before we graph is things like our maximum, our minimum, and then any kind of intercepts, right? Where's the x-intercept? Where's the y-intercept? You're going to eventually have 5 different points. You're going to eventually have 5 different points. And it depends, right? With cosine, you're going to have 2 maximums and 1 minimum, and then 2 x-intercepts. Whereas with sine, you're going to have 1 max, 1 min, and a couple of and 3 intercepts. So that's why I say there are 5 points. It just depends on which one you're looking at. Before we change our value in Desmos to 2 times cosine x, does anybody have any idea of what it might look like? How it might change the graph? Yep. Yes, right? The whole point, right? Called vertical stretching. We're going to stretch it, right? It's going to change the value of our range. It's going to change the height. So go ahead and put in 2 cosine x. You can see what it looks like. And we'll go ahead and graph it on here, although it's very similar. And just like Alyssa said it would, right, instead of going up to 1, it now goes up to 2. Instead of going down to -1, it goes down to -2. So as I draw this, it's going to be up here at 2. So it's going to kind of stretch out my function, vertically stretch it up. So our domain, right, is still going to be all real numbers. I still can plug in whatever I want, even though I changed my cosine function a little bit. The big thing that's changing is now my range is going from -2 up to +2. So without putting this next one into Desmos yet, what do you think 1/2 times cosine x is going to look like? It's going to shrink it down, right? It's going to be the exact same function, but it's going to change the range. That's now just going to go from -1/2 to +1/2. So that number out in front, right? If we have any kind of number out in front here, we label it with an A because it has a special name. It's called the amplitude. And it really means the height. What is the height of my cosine function? What is the height of my sine function? When we talk about amplitude or some, if on a question on a test, it's what's the amplitude of this function? It is always going to be positive, and it is always just the number that is out in front of the cosine or sine function. So we've now, right, we've kind of vertically stretched or shrunk this particular graph. But what happens if we tack on another number at the end here? What if we have, do you guys still have 2 cosine x in there? What if we add a little +3 to the end? Go ahead, put that in Desmos. How is that going to change my graph? So did it change the cosine function? Does it still have that same height? Does it still have that same amplitude? All it did is it took that cosine function and shifted it up, right? It shifted it up by 3 units. So I know this goes on to the next page in your notes. When we just have A times sine of x or A times cosine of x, my amplitude is always just A, and my range is very easy to figure out. It's just -A to +A. But what happens if I tack on that +3 or whatever plus value or subtract value, right? If I've got a plus C, that's the letter that mathematicians use, right? Just throw every letter in the book at it. My amplitude is still A. The height of my function is still the exact same thing that it was before. But my range is going to change. It is now -A plus C, all the way up to +A plus C. And you can always verify this information, right? You can always verify it in Desmos to see, am I really calculating the range correctly? We can now do it algebraically, but let me just double check visually and graphically. Questions? Okay. So we've done the whole vertical stretching, and we've done the vertical translation, moving it up. Now we're going to do the whole horizontal stretching idea. So go ahead and remove everything that you have in Desmos right now, and let's type in just regular old sine of x, and then sine of 1/2 x or 0.5 x, and then sine of 2x. Let's put all of those in there. And this is where you may want some colored pencils to kind of graph all of these things. So we know what the sine of x is going to look like, and I'm going to put it on here just so we can kind of see the differences. So there's our sine function, our regular old sine function. Now, a half of an x, so I'm only showing 0 to 2 pi on my x-axis here. So for my sine of half of an x, right, I never actually get to see the entire full period just by looking at that 2 pi section. Whereas the sine of 2x, I still start at 0, but now I'm going to shrink this down a bit. And I'm just showing one cycle here for each of those. Does everybody kind of see the same things on Desmos? They're a little crowded, different colors. So go ahead and, knowing, right, the graph that I have up here on the board, try to fill out these things here, right? What is the period of all of those different values there? Right? The period is going to be how long it takes to do a full cycle of sine. All right, so what is our period of our regular sine function, sine of x? How long does it take? 2 pi. Now, how about a half of an x, sine of half of an x? 4 pi. Right? Here, I'm only seeing the first half of it. The second half of it is going to take another 2 pi to go the full cycle. And then our last one, the sine of 2x, pi, right? It only took pi to get a full cycle of the sine curve there. So when we talk about how this b value, so now we're adding all these letters, right? A, B, and C. The b value is the value right in front of the x, inside of that sine or cosine function. That is going to horizontally stretch or shrink, which changes the period. Right? Before we were changing the range, now we're going to be changing the period value just by putting a number in front there. And so the question is, okay, if we're horizontally shrinking or stretching, changing the period, what's kind of the rule of thumb? Well, the rule of thumb is if you have some kind of a fraction, right, a number between 0 and 1. Notice I'm always looking at absolute value here. Right, so whatever the number is in front of x, I take the absolute value of it, that's going to be stretched. Whereas if my absolute value of b is greater than 1, if it's a bigger number, right, it's going to shrink. We're going to compress it down. Compress, shrink, whatever makes the most sense to you. And of course, right, is there an equation for that, Ms. Sudlik? Of course there's an equation for that, right? Can we algebraically back up all of this work, right? We can see it graphically. We can see it visually. So how can I calculate the exact period value, right, when I'm given a function like this, and all I care about is that b value? Well, all I do is I do 2 pi divided by b. So this is a formula you're going to have to memorize for the test, is to know, okay, how do I back out the period? How do I figure out the period if I only have the value b? So let's do some examples. I know there are 8 in your notes. We're going to just do 4 to make sure you feel comfortable doing the homework, because primarily the homework is this. We want to calculate these 3 things: amplitude, period, and range. So let's look at letter A. The amplitude value is the number in front of cosine or sine. So what number is in front of here? 1. So my amplitude is just 1. Which means that my range value, right, I'm not adding or subtracting anything here at the end. So my range is just -1 to +1. Questions on where we got those? Okay. Now the last piece is to figure out the period value. I could put this in Desmos and see, but let's see if we can figure it out algebraically. So my period is always 2 pi divided by that number in front of x, divided by 1/3. I know, dividing fractions. I put a lot of fractions on this one, sorry. You multiply by the reciprocal, 6 pi. So if we were to put this in Desmos right now, we would see it would take a full 6 pi to do a full cycle of cosine. Let's jump down to do letter C. Okay, what's my amplitude for letter C? 1/3. And since I'm not adding or subtracting anything at the end, my range is just -1/3 to +1/3. And then last but not least, we have the period value. Now notice this one, right? I'm trying to make sure we hit all of our bases with all the different types of things. This one, the number in front of the x, has a pi in it. So I have 2 pi divided by 2/7 pi. So my pi's are going to cancel. And then we've got to do some fraction math. 2 times 7/2, 7. So in this case, right, the period value that I get does not have a pi in it. If we were going to be looking at this on Desmos, we'd probably want to remove the step of pi over 2 and just use regular tick marks of 1 up through 7. So we can see that full cycle. Questions there? Couple more examples. Let's keep going down this column. Letter G, or letter E. Then we'll do letter G. What's my amplitude? 12. It's always the number out in front. Now my range, I've got to take into account this +2 at the end here. So I'm going to go from -12 + 2 up to +12 + 2. And you can definitely do that calculation in your head, right? -10 up to +14. And then the period value, I'm going to do 2 pi divided by 4/3. No pi in there. So 2 times 3/4 equals 6/4, 3 pi over 2. Go ahead and try G on your own, or let me know if you have questions on those 2 that we've done so far. Feel free to use your calculators for that fraction math, but what we're doing for here, fraction calculus. over these here. My amplitude, right, is just that 1/4, that number out in front. My range is going to be negative 1/4 plus 3 up to positive 1/4 plus 3, which, positive, not negative. 11/4 up to 13/4. I did not write them in those numbers or think of them that way. And then my period, we have 2 pi divided by 5/6, 12 pi over 5. Questions there? Okay. So the majority of your homework assignment is really just doing that amplitude, period, range. Amplitude, period, range. Feel free to use Desmos, though, to check your work as you go through those. Your other homework assignment, right, is those word problems. Hopefully you got most of those equations set up, so then you can just go through and solve them. At this point, we have now finished this unit. So next time I see you, we will be reviewing. Yay!